Hello everyone, welcome back to our data mining course. So in the previous lecture I would have explained about data pre-processing, and also I have given a general view on how the data could be processed and what are the steps we have to follow, and also what are the mathematical outlets you have to follow, that also I have given. So today in this video I'm going to explain on detail about how the statistical descriptions of the data is applied. So before applying any data mining algorithms, we must first understand the data. So let me ask you a simple question. Suppose I give you the marks of 500 students, and do you think we can analyze all 500 values one by one? Of course not. It's a tedious process, and you have to do it manually. It will take more time for you, right? So instead we summarize the data using a few statistical measures, like you have studied in your school days, like mean, median, mode, range, quartiles, etc. So these measures help us understand the overall behavior of the data set. So before data mining algorithm discover patterns, they first analyze these statistical properties. So that is the main motivation of this lecture, why we have to analyze the statistical properties. So let's start the session. So statistical descriptions of the data. So as I said earlier, it is before we analyze any or discover the patterns, we should understand the properties of the data which is given. So that is the main motivation. So here it could be used to identify the properties of the data and also highlight which data value should be treated as noise and outliers. So I have given enough examples of what is noisy data and what are the outliers that that doesn't belong to your clusters in the data pre-processing. So go through it. So measuring the central tendency, we have mean, median and mode. So how the mean is calculated? Sum of all the values divided by total number of values. So look at this example. So here they have given the range of values from 30, 36, 40, 47 till 110. So what we have to do? We have to take the mean. How do we take the mean? So we have to add up all the values divided by total number of values. So in the numerical part, you have to add all the values and divide by the total number of values, right? So from 30 to 110 we have 12 values, so that we have to do it. So this is mean. So next, what is weighted arithmetic mean? So let's see that. So basically, before I explain, let me ask you one thing. So do all university subjects have the same number of credits? So you will be studying, if you take engineering course, you will be having 8 semesters, and do all the subjects have the same credits? Of course not, right? So some subjects may carry like 4 credits, 3 credits, and maybe 2 or maybe 0, right? So should all the subjects contribute equally to your CGPA? So of course not. So subjects with more credits should have more importance, right? So that is why we have to use this weighted arithmetic mean. Okay, so the formula is x bar is equal to the weight, the importance which you are giving. For example, the credit, right? So w1 into x1, the data, x1 is the data, plus w2 into x2. So w1, w2, wn, that represents the weights which reflect the significance or importance, or the frequency, the occurrence, right? And x1, x2 as usual your data divided by total number of weights that is present in your data. So this is called the weighted arithmetic mean or the weighted average. So this is why we have to choose weighted arithmetic mean. Next, we go to median. So what is median? So basically, this median is used to calculate, again it represents a statistical description of your data. So why we have to go for the median when we have the mean and average? So let me ask you an important question. For example, you have 5 employees and they have the salaries like 20,000, 22, 25, 28k, 5 lakhs, right? So now what do you think the average salary will be? So we have to add up all the salaries and divide by total number of values, right? So the average salary you will get it. So you have to add up all the salary divided by total number of persons. So now think carefully, do most employees really earn 1,19,000 or 20,000? Of course not. So from the data what I have given, 20, 22, 25, 28, then 5 lakh, right? So only one employee earns 5 lakh. So the average is misleading because of one extremely high value. So this is where the median become useful, right? So median simply means the middle value after arranging the data in ascending order. So think of students standing in a line according to the height. The student standing exactly in the middle represents the median. So unlike the mean, the median is not affected by very large or very small values. So if n is odd, then the median is the middle value of the order data set. And if n is even, the median is not unique. It is the two middlemost values, so you can take any one between that, right? So here the example is given. I have total number of values 12 and the value starts from 30, 36, 110, like the same previous example I have taken. So what is the median here? You have to take the middle value. So here I have the 42 plus 42. Since it is even, you have to take the two values, right? So two middlemost values you have to take. So 52 plus 56 divided by the total number of values. Only two values I am taking, two middlemost, right? So I will be getting 54. So the median is 54,000. So if it is odd, so you don't have to bother about the two middlemost. You have to take only one, right? So that example also given here. So this is what the median. So moving on to next, we have mode. So what is mode? So basically the mode represents the value that occurs most frequently in the data set, right? So it is possible for the greatest frequency and also the lowest frequency, right? So if it is greatest frequency, then it corresponds to several different values which results in more than one mode, right? So if it is one mode, then it is unimodal. If it is two mode, then that is bimodal. Then if it is three mode, then that is primodal. And if you have more than three, then it is called as multimodal, right? So if each data value occurs only once, then there is no mode at all, right? So why we have to go for this? Let's see. So mode simply means the value that occurs most frequently, as I said. So unlike the mean, we don't add anything. Unlike the median, we don't arrange anything. We simply count how many times each value appears. So that's what basically the mode here, right? So for example, here also I have taken the same previous example. So what is the mode and what kind of mode? So here if you take this, I have 52,000 which is occurring twice and also 70,000 occurring twice, right? So since there are two modes in this, I have the bimodal. So you have to calculate how many times each value that appears. That is the importance of mode. Next, moving on to mid-range. So what is mid-range basically? So suppose minimum mark is 20 and maximum mark is 100. Then how do you calculate the mid-range? You have to take the starting value 20 and the maximum mark 100 divided by the total number of values 2, which is nothing but 60. So here also I have given the same example. If you take this, I have the starting value 30. Here everything is represented in dollars. So 30,000, right? 30,000 plus the last value is 110. So 110,000 dollars, right? $1,10,000 divided by only two number of values I am taking, 30,000 and 1,10,000. So I have total number of values 2, so which is divided by 2. So I have the $70,000. So this is what mid range. Take the minimum value and maximum value. So mid range uses only these two both. So it completely ignores all other observations. So because of this reason, mid range is not used very often, because I am not giving any importance to any other data or any other values that is present, right? So because of this, what will happen? I'll get the skewed data. So what is positively skewed and negatively skewed? So skewness tells us whether the data is balanced or stretched or towards only one side. So if it is positively skewed, the mode occurs at a value that is smaller than the median. So you have your median, you have calculated, right? So if it is positive, then it is smaller than the mode. So the negative would be just the opposite. The mode occurs at a value greater than the median. So this is what positive and negative. So because of this reason we don't go for the mid range mostly. So next it's about another important statistical description: range, quartiles, outliers, and box plots. Right. So far we have measured the center of the data. Now let's measure how much the data spreads. Right. So to know how your data is distributed, you have to go for all this: range to box plots. So what is range? Let me explain with a simple example. Suppose marks are given like 35, 40, 45, 70, 95. Okay, assume. So the highest is the 95 and the lowest is 35, right? So what will happen? How do you calculate the range? The maximum to the minimum. So maximum minus minimum. So 95 minus 35 equal to 60, which is very simple. So basically the range is nothing but the difference between the maximum and the minimum value. So the most commonly used percentile other than the median or quartiles, right? So what is quartile? We will explain. Suppose you have quartile divided. For example, assume you divide the data into four equal parts. For example, I have 10, 20, 30, 40, 50, 60, 70, 80, right? So now q1 is first 25 percentage, q2 you will take the median, q3 you will take the 75 percentage, right? So the distance between the first and third quartiles is simple measure of spread that gives the range covered by the middle of the value, right? So the distance between this q3 and q1, I will leave the mid one. This is called as IQR. So you can specify the range. So interquartile range, basically this is the formula: q3 minus q1. Okay. So next, 5 number summary, box plots and outliers. So here I have given the example. So here they have given the values from 34 to 27. So you can take like this how this quartile is represented, right? So I will be taking the first three values: first 25, second and next three values 25 percentage, next third quartile I'll be taking the another three values, and fourth quartile I'll be taking the last four. So since I have 12 values, I will be able to distribute the quartile equally, right? So next we have the another one, box plots. It's an efficient way to popular and also another popular way of visualizing a distribution, how you could see your data, right? So for example, here I have the data I1, I2 to I5, right? So if you want to put a block between the range, then you can go for this box plots. So the median here is 19, right? So the median of 6 numbers that are less than the 19 is 15. So the lower quartile is 15. The median of the 6 numbers that are greater than 19 is 25. So the upper quartile is 25. So 15 to 25. So this is what you can represent with this box plot, the lower and the upper. So here also I have another example, same it is represented with a different three examples. So you have to calculate the lower one, the median one, and also the upper one. So from that you will be able to represent the box plots. So next one, it's about outliers. So a common rule of thumb for identifying suspected outliers is to single out values falling at least 1.5 into IQR above the third quartile. So what they are telling this exactly. So why I have to go for outliers exactly? So when you have many data, you cannot say all the data have the same properties or the same similarities. Some data will have similarity and some may not, right? So to distinguish between the data, we have to go for the outliers. Which data doesn't belong to my cluster? That is basically outliers. So the formula to do, the simple algorithm here they have given. So the interquartile range q3 minus q1. So how to test it? First you have to find the IQR, then multiply the 1.5 into IQR, then subtract the q1 minus 1.5 IQR. Then you have to add the q3 with this, then you will be able to find out. So any value less than the value in step 3 or more than the value in step 4 is basically an outlier. So this is a simple algorithm how to find out the outliers. So why basically outlier matters? So outliers are extremely important because they often indicate errors, frauds or unusual events that is present in your data. So you can take any simple example, the previous example you can take, and you can calculate this and you will be able to find out the outliers. So next it's about variance, standard deviation. So variance and standard deviations already would have studied in the school. So how to do it? So you will be given with a set of values, and the formula to find out the standard deviation is x2 minus x1 the whole square divided by the total number of values. So here I have 5 5 5 5, then 4 4 6 6 and 3 3 7 7. I have different values of data. To find out the standard deviation, I have the states 0 1 2. 0 belongs to 5 5 5 5, 1 has 4 4 6 6 and 2 has 3 3 7 7. So sigma 1 is equal to so x minus x2 minus x1. So 5 minus 5 the whole square plus 5 minus 5 the whole square. I have 4 values, so x1 x2 x3 x4, right? So total number of values 4, so divided by 4. So I will be getting this. So next it's about sigma 2. So the same way you have to calculate this. So next it's about the variance. Basically how to find out the variance. Sigma square is equal to 1 by n summation of I is equal to 1 to n xi minus x bar. The mean you have to take it the whole square, right? So where x bar is the mean value of the observation. So these are the basic statistical description or properties you have to know to analyze the importance of your data. So we have many more concepts also. So today I have given the general view why we have to go for this. You can also use the histograms, scatter plots, cube plots to represent your data, right? So today I have given general view on, like, mean, median, mode, quartile, range, box of plots, then the variance, standard deviations, right? So you all can use this. And also I taught about outliers to analyze the importance. So this is about why we have to go for the statistical descriptions of your data. So we'll see in the next lecture. Thank you all.